My name is Zahorski Philippe. I'm head of sales for Pan-EU for Amazon Web Services. So I'll take you today through a bit of what we do. We're not necessarily spoken about that much. We like to give examples of what our customers do, so I'll give you a few examples of what our customers use AWS Cloud for, and actually some of you guys as well, how you use us. So let me give you some basics about Amazon Web Services. So there's 4 elements that we define cloud computing by. The first one is on demand. So being able to use compute, storage, any other services as you need it, when you need it, only when you need it. The next one, the next definition we think about is uniformity. So being able to use across the world our services in a uniform way. So what works in one place should work in another one. It should scale up, should scale down, and it should be easy to use. The third definition that we use cloud computing with is pay as you go. So you only pay when you use. There is no need to pay upfront. There is no need to pay subscriptions. If you use it, you pay for it. If you don't, then you don't pay for it. And finally, it's availability, making sure that the services we provide are always there available for you, but also being able to build services that are defined on your availability. If you need more availability on services, being able to combine those services to make your applications more available, for example. If you need storage to be more available, be more consistent, then you can combine storage methods and actually make more, have higher service levels for that. This is how we think about cloud computing. Our Amazon Web Services business model functions on 4 principles. Economies of scale. The more customers use certain services, the more we can scale, the more we can lower our cost structure, because we can purchase at a higher volume storage devices. We can purchase at a higher volume compute devices. And our principle after that is to pass on that saving to customers. The example to that is that since 2006, we've reduced our prices 52 times. Actually, we've announced a price reduction that's going to take into effect next month. It's our 53rd. What that gives to our customers also, it gives a rapid pace of innovation. What customers individually try to do in terms of innovation can be done at aggregate scale, and that's what we do. So based on the customer demand, we always innovate on their behalf. So instead of having customers having to innovate in their own individual silos, we innovate on them. Actually, the result of that is Gartner. Gartner's definition of AWS was that it's positioned the highest in execution and furthest in vision within the leaders quadrant. So if you look at the top right, you look at where Amazon Web Services is. Worldwide, enterprise customers use us. I'm sure you're not surprised. I'm sure you recognize some of the names there. You can look at Salesforce. You can look at Pfizer, Kellogg's for your breakfast, the Discovery Channel, for example, the Coca-Cola company. Those are all companies, enterprise companies that use Amazon Web Services. But what's available to those enterprise customers is also available to public sector customers. So if you look at some of the examples we have within public sector, within government institutions like you guys, you've got the Swiss government, or UCAS, which is admission service for the UK government. Transport for London, which I'll give as an example a bit later. The European Space Agency, and also some other US government agencies. If I took an example of UCAS, for example, they've had for, I don't know, many years, their website was crashing. What UCAS does, I don't know how familiar you are with, but in the UK, there's one day in the year during the summer where all the students check their results and actually look where they're admitted. As you can imagine, every student goes and looks at their logon, then tweets their grandmother or emails their grandmother to actually check, look at the high grades I got, multiplies, which means that every day, every year, once a day, there's a huge spike of traffic. What UCAS has done is they've used Amazon Web Services to actually cater for that spike. So most of the year, they use very little compute. And then during that spike, during the year, they augment their capacity and pay just for that. So instead of provisioning all year round for that capacity, they just provision for that day for that capacity. Made a huge difference, and that website has been available for the past 4 years. In terms of our infrastructure, I think my colleague earlier spoke about data availability. Where is data? Let me take you through a few examples. So how we define our global infrastructure is through 2 or 3 key concepts. The first main one is the concept of region. We've got 15 regions today. In Europe, I'll take you through a bit the ones that are in Europe, but those regions are uniform and placed around the world. What's important to remember is our regions are segregated. And what that means is that customers choose where the data is within those regions. So Amazon Web Services, if you put your data in one region, it will always stay within that region, unless you decide to move it. Which means that they're by design, isolated. Which means that by design, the data will not move outside of that region, unless you choose to do so. Which, if you think about it from a European context, if we have 2 regions in Europe, we've announced 2 more, but today we have a region in Ireland and a region in Frankfurt. You can build scalable application, redundant application, with the data never moving outside of the EU. Of course, there are certain services that need the data to be moved out, which is what we call edge location, which is when you need to service your customer closer, which you can use. But the core infrastructure, you can build it, is within the EU region. In terms of services, I think if there's developers around here that code probably know or frustrated by this principle, get an idea, got a great idea. And by the way, this applies to startup, but it also applies to project within government. So you get here, oh, well, maybe next year we'll be on a roadmap, do this change order. It'll take 2 months to execute. Oh, we can't do it. Well, on Amazon, it's very different because what you do is we've got a huge palette of services. I'm not going to go through all of them, but you can pick and choose what service you use and just code for that service or just design on that service. And again, those services are uniform and available in regions within Dublin, for example, or Frankfurt. So you can decide where that service is going to run, where the data is going to be living. An example I said I would talk about earlier is Transport for London, TfL. I'm sure most of you have been in London. There's about 30 million journeys happening on an average day in London. Huge infrastructure that works rather well. Well, TfL decided to use Amazon Web Services to support that infrastructure in terms of presence on the web. So that application does arrival prediction for the tube, the DLR, the river, the buses. It also controls up to a certain extent taxis. And every day they have to do 130,000 arrival predictions and publish that to the world. Well, most days that's okay. I mean, that's an infrastructure that runs pretty consistently. I mean, it's large, but it still runs consistently. What happens is, apparently my colleagues in Amazon always say that winter's coming, but snow days arrive. And then what happens is you've got a peak of users asking for that information, asking when is my bus going to arrive? Well, if TfL had to cater for that all year round, they would have to cater for those storage capacity and a CPU capacity all year round. What they can do with a cloud infrastructure is cater that spike and scale up on that spike automatically and then scale it down. The previous CDN solution had a limit. It had 20,000 requests per second. Now they can scale up the CDN as they need it and pay only as they need it, and then scale it back down. So, cloud allows you to move your expenses from fixed to variable, so it allows you to only pay when you need it. You don't need to guess what your demand is. If your website is going to be very successful, if your internal application is going to be very successful, you don't need to know it in advance. You can scale up as it becomes successful. You don't need to manage infrastructure. Most businesses and most government organizations are not in the business of running infrastructure. We do that on their behalf. And finally, because it's consistent, you can go global in minutes. You can go global within the EU, or you can global within the world. If your application needs to service satellite data all around the world, you can do that consistently very easily. But what a true cloud computing infrastructure allows to do is allows you to choose. I don't think anybody should be able to dictate what application you should be using, what database you should be using, what storage devices you should be using. So within Amazon Web Services, what you can do is you can use Microsoft application, or you can use SUSE, Linux. You can use Ubuntu or Red Hat. In terms of databases, you can use Microsoft SQL to MySQL, or DynamoDB, for example. Or, for example, quite innovative new databases like Amazon Aurora. But you should be able also to change your mind relatively easily. I mean, going from an Oracle database to a MySQL database on-prem is very, very hard. Within cloud, you can experiment and you can try. So if you actually want to start with an Oracle database as your backend, you can do that. And then very, very easily move, if you decide to do so, to an Aurora database or as a Microsoft SQL database. This can be managed or you can host it. It's up to you to choose. Finally, security. I think my colleague earlier mentioned security being one of the big concerns. Your cloud provider should and has to be certified and accredited. You going and checking a data center is not a scalable way of doing that. You have to rely on international certifications. Those are some of the ones that Amazon has. But that's all well and good, but you should also be able to control your infrastructure. And services like, for example, Amazon Web Services CloudTrail allows you to view every single interaction that has happened in your infrastructure. In today's in an on-prem infrastructure, it's extremely hard to do. It's extremely hard to keep all the change requests that happen in your environment. In a cloud environment, it's a software. It's a software switch, so you can actually track all the changes. In terms of what the industry says about us, the Forrester Wave, you can actually see where Amazon Web Services is rated in terms of leader by Forrester. Just to give you an idea. Finally, just a small nod to some of your colleagues that have started using Amazon Web Services. So DIGITEC, they have launched their first website on Drupal on Amazon Web Services. You can look at the infrastructure there. I should give you a bit of a, I mean, I'm sure you can read what's there, but I'll give you a bit of a point. The guys came to us and said, well, we're going to have a high peak of traffic. We're going to have one peak load for 1 million users for 10 hours. I think they were going to say it's twice a year. I think that's what they predicted. I wanted to see what the cost was going to be. So we looked at the infrastructure, what infrastructure we're going to bill, and the bill was about, for each cost, it was going to be $50. $50 each time there was a peak load of 1 million users per hours for 10 hours. 50 euros, so 100 euros over the year. So just to give you an idea of the cost difference. Try to do that by trying to do it on-prem, and the problem is much, much, much more different. There you go. Hope this gives you quite a summary of Amazon Web Services. Have any questions, give me a shout over email. There's a few of us as well in the audience if you want to ask us. Thank you.
Okay. Thank you very much.